and welcome to Chem 420 office hours. Welcome back after spring break. This is our first class. I don't know how many humans are going to be joining us tonight, but I can see a couple. So I want to say hello. Just a couple things. This is going to be our plan, or my plan is I'm going to be available to all of you, both lab sections, in kind of an open office hour format. We have, excuse me, nothing better for a live stream than clearing your throat right into the microphone, right? We've got, we're fully, as you already know, in remote education, right? Online learning. And so we're done with physical labs for the semester. And as a result, all of our lab experiments are online. And there's going to be a mixture of like the last lab we did was purely online. The next one actually is ready to post. I'm going to be dropping that one in an announcement on Canvas tonight, actually. Once this is done, it'll be another online exercise, and it gives you data, kind of gives you prompts for how to analyze it, what to look for, what to calculate, with a couple post-lab questions thrown in for good measure. But that you can all do on your own time. And the decision that kind of the place both Max and I came to is we felt that it would be the best use of our contact hours, my contact hours in my lab section, to just host online office hours so we can talk about absolutely anything course related that you are struggling with. I can clarify points, maybe present them in a different fashion. We can work problems together. You can hit me with lab questions. And by way of kind of a reminder, so I'm going to be here every Monday and Wednesday. All right, so this will be Monday and Wednesday at 6:30. I'm going to be chilling, hosting these office hours. And again, you do not have to be in my lab to attend. This is for anybody who's taking Chem 420. So I'm going to be here. You may or may not be able to come. I know at least initially, when the semester was underway, everybody in my lab section could make it, but things may have changed. You may have altered your work schedules based on the fact that COVID shut down all physical classes. And if you're not able to attend live, you can still get your questions answered. You can submit them over email or to my Canvas inbox. If you do email submission, so email question submission, I guarantee your questions will be answered to the best of my ability. How well I'm able to answer it will partially depend upon how clear the question is. So, for example, if the question is, "Can you explain all of Chapter 6 to me?" The answer is I can, but I don't know what specifically in Chapter 6 you want to hit. So I would probably do a general summary, but you might find that disappointing. However, if you said, "I'm struggling with Section 6.3 and 6.5, can you explain those?" That would be a lot more useful. I'd be able to give a more detailed recap. When you email your questions in, there are two things that would make it a lot easier for me. The first is if you could have in the subject line, dyslexia makes life a lot more exciting. in the subject line, if you could include Chem 420 office hours, that'll make sure that I don't miss your email. And then for the second thing, if you could also attach a picture of the problem that you need help on. That way I can kind of compile everything. I make a little list for myself where I've got all the problems lined up. That way I can see what questions need to be answered, what subjects they are. Maybe I can clump a few together. But anyways, that would be very helpful for me in organizing the stream, making it as fluid as possible with minimizing dead time. So I will continue to be here to answer any questions that you may have related to course content or procedurally, deadlines, all of that good stuff. So anyways, I wasn't exactly sure how this particular session would go. It's our first session after spring break. I haven't received any emails or Canvas messages with any questions, so I don't have any pre-prepared. So if there are no live questions, then we'll be concluding this stream rather soon. Because I think the last thing anybody wants is me rambling into a mic talking about nothing for 3 hours straight. I am totally down each office hour to stay, the full 3 hours. But in the absence of questions or comments, subject material, then I'll be concluding them rather shortly. But what was I going to say? Oh, right. So this is my question right now is, are there any questions? I can see there's a couple humans. So I don't know if any of you have ever streamed to YouTube, but the way they do the kind of the live stream studio setup is I can see the total number of concurrent viewers. However, I cannot see the identity of anyone who's watching. So I get to see the total number, but it doesn't tell me the name. So as of right now, I know that I'm here sitting in a digital room with two other people who haven't commented, so I don't know who you are. You're sitting in the dark, and if you value your anonymity, there's nothing I can do to change that. I'll continue talking to your blank, dark, expressionless face, trying not to get nervous. But to be fair, you can't see mine either, at least not yet. So you have to be content with that little robot sitting in the top right-hand corner. So you guys took an exam, second exam, right before spring break. I saw that was, oh, hey, what's up, Fuzel? How's it going? What up? Sweet. Now I know who one of the two humans are. I hope everyone's spring break was awesome. So I usually don't have plans for spring break anymore. Usually spring break is that time where I don't have to go to work for a week. But believe it or not, I actually had plans this spring break. And my wife and I made these plans towards the end of last semester. So I don't know. some of you know, at least my lab at least knows. I went to a grad school in New York. I'm a Southern Californian, born and raised, but I did grad school out at NYU in Manhattan, and I graduated in 2014. Haven't been back since, and so my wife and my kids have never been to the East Coast, and my youngest is just at the age where he's like, we don't have to buy him a plane ticket yet, so we're like, why not do a East Coast trip? She was born in grew up in Pennsylvania and has family, friends back there, places to stay. So we were going to go out and do it. We had our tickets, everything, and it was before COVID was a twinkle in anybody's eye. So obviously we did not go to New York for spring break. Instead of going to New York for spring break, I sprained my ankle on Monday of the spring break. I wiped out on my one wheel, and I bailed and I rolled my ankle. So I spent spring break with my foot elevated, grading. I had a Gen Chem test that I graded, and then I got cut up on 3 OChem lab reports. So that was my exciting stories of spring break. Yep, that's about all I have right now. Hey, Raj is there. What up? As you can see, we're bursting at the seams with questions here, so I will take any at any time. In the absence of questions, I'm just gonna continue talking about how my ankle is sore. I actually got out on my board for a ride yesterday, which felt good. Couldn't really do the normal distance because again the ankle, but it felt good at least to ride again. We've got a few more humans join in, or at least join in the stream. Feel free to pop in a question and let me know what's up. Let's see. I am going to need Google Translate. Well, nice. Okay, just wanted to make sure I wasn't missing an OChem question in another language. Yeah, so that's what's going down with me. Actually, I think we may have some questions coming, especially now that I see Raj has joined the chat. We may actually get some OChem content in here. But while I'm waiting for questions to pop in, I might start working on uploading the new online lab report, which is about radical chlorinations. Yo, going over some nomenclature, the differences between isopropyl and isobutyl. Yeah. Okay, sweet. Let's get into this. Oh, where am I? All right, so nomenclature. So when we talk about substituents. All right, naming substituents, particularly I should say, I'm going to need a lot more room. When we're talking about isopropyl, isobutyl, we are talking about saturated hydrocarbon. Saturated hydrocarbon substituents. All right. They all end in YL, ill. So like methyl is 1, ethyl is 2, propyl is 3. Oh, Fuzel, I see you said here, hang on one second. I will. Fuzel, after I'm done with Raj's question, I will look up that that email. Thanks for letting me know. So saturated hydrocarbon substituents end in YL. So if you have a, for example, a 3-carbon substituent. So here, clearly the substituent is this chain because it has 3 carbons. When you look at the larger ring, this has 6 carbons. So the ring is the parent, and the side chain, the 3-carbon side chain, is the substituent. Because the side chain has 3 carbons, we say that it is a propyl. Propyl side chain. All right. Now, if you'll notice that there is actually more than one way to attach this 3-carbon side chain. You can see that here in the first one, it's attached at carbon 1, but it's also possible to draw this structure where the point of attachment is actually on the 2nd carbon of the 3-carbon side chain. Right? Now, the proper IUPAC way to name this is as follows. All right. So the IUPAC name here would be 1-methyl ethyl, close parentheses. So this gets its own unique parentheses. 1-methyl ethyl actually, we don't need the parentheses here. 1-methyl ethyl cyclohexane. Actually, we do need the parentheses. Take that back. The reason why we need the parentheses is because this yellow piece is an ethyl side chain, right? It is a 2-carbon side chain right here with a methyl attached on the 1st carbon of the ethyl. If this is 1 and this is 2. So that methyl is on the 1st carbon of the ethyl. The ethyl's 1st carbon is where it connects to the cyclohexane ring. So the IUPAC name is 1-methyl ethyl cyclohexane. However, when you look at that 3-carbon chain, you're like, it kind of looks like a propyl group. It kind of looks like a propyl group. So, oh, okay. Well, Roger, I am going in depth, into that, and I can go over it again if it's still not clear. Another way to look at this is it kind of looks like the propyl group, but it's not the same, right? With propyl, it's attached on the end carbon. With this one, it's attached at that center. So this is called shorthand, but also IUPAC acceptable, is when it's attached on that 2nd carbon, that this is isopropyl. So you could also name this, and it's easier to name it, isopropyl cyclohexane. All right, so that's where the iso comes in, because it's kind of like the propyl group. It's a 3-carbon side chain, but it's not attached at the end. And people find calling it isopropyl easier than calling it 1-methyl ethyl, if that makes sense. How's that? How does that sound? Let me know. Let me know what you're feeling. All right, so that's where isopropyl comes from. It's essentially a propyl side chain, but where you're attaching it at the second carbon of that propyl side chain. The point of attachment to the main chain is on the second carbon as opposed to the first. It's a bit raw, but you can take Fuzel's question. Okay, well, I can come back to the... Let me just hit the isobutyl while we're here. And then move on, just so we keep the topics that are related together. So that's isopropyl. Now with butyl, oops. So if you look at this side chain, there's 1, 2, 3, 4 carbons, right? 4 carbons here. We still have 1, 2, 3, 4, 5, 6. So with 6 carbons, that is our main chain. Here, we have a 4-carbon side chain, right? So this would be well, actually, before I name it, I'm going to draw a couple more. All right. This is not the only type of butyl side chain. So, for example, in the 1, 2, 3, 4, in the first example, which I'm going to call A, we had the butyl side chain attached at carbon 1. Here, we have a butyl attached in this one. I'm going to call this example B. The butyl's attached at carbon 2. There's another way to attach a butyl side chain. You could look like this. C. Then fourth and finally, oops, with example D, we could have a 4-carbon side chain that looks like this. All right, all of these have 4 carbons. So they're all butyls of sorts. Yep. But they need different names. So we call A, the name for A is n-butyl. And the way I remember that is it's attached at the end or end. All right, that's the mnemonic I use there. For B, this is called, as you already know, sec-butyl. Because again, here, the way I remember it, it is attached at the second carbon. The third one, letter C, is isobutyl. The reason, or how I remember it's isobutyl, is because to me, it kind of looks like isopropyl. So that's how I remember that name. And then the last guy is the infamous tert-butyl. Is the final guy there. So that's how, that's where isobutyl comes from. It is the 4-carbon chain, so it's a butyl. It kind of looks like iso. I don't know if that's why they named it that, but they did, and that's how I remember it. Does that make sense? Hopefully that makes sense or clears things up. Let's see. Oop. Oh, sweet. Okay, hang on one second. I'm going to check out Fuzel's question. Let's see. Question number 6. Okay, sweet. All right, Fuzel, your question is rad. Hang on. Here we go. Fuzel, your question is totally rad. All right, let's take a look at this. This is getting into some cool beans. So this question was problem 6 on a thing that Fuzel sent me. I don't know where it came from, but let's take a look. So we're given a reaction scheme. And we're asked to predict the major product and rationalize the regioselectivity. So we're given a substrate. Next, we're given reaction conditions. So HBr, and then a fun thing that looks like this. All right. And we're not told what the product is. And we're asked, oh, this was on the test. This thing is the test. Okay, sweet. So let's take a look. So we're asked to, in this question, we are told to, draw the major product. Draw the major product and explain the regiochemistry. All right, draw the major product and explain the regiochemistry. Now, here's the deal. Here is the deal. So first, before we can draw the major product, we need to know what kind of reaction we're dealing with. And whenever you see this character, all right, whenever you see this dude in play, this is going to do one thing and one thing only. And that is make a radical. All right, so this is a radical reaction whenever you see this reagent in play. All right, and we can deduce from the fact that we have HBr that not only are we dealing with a radical, but we're dealing with a radical bromination. All right, so we've got a radical bromination in the works, and we know that by looking at the reaction conditions. Now, if we're going to do a bromination, we know that we want to form that the major product is going to come from the most stable radical, right? The major product comes from the most stable radical. And if you're wondering what stabilizes a radical, this is a great thing to have in your back pocket. What stabilizes a carbocation also stabilizes a radical. So this works. Ooh, I'm running out of space. Oh, here. Hey, okay, hang on. I just need a little more room to roam. All right. So what stabilizes a carbocation also stabilizes a radical, right? When you think about it, whoa. What stabilizes a carbocation stabilizes a radical. When you think about it, both carbocations and radicals are breaking the octet rule, right? They have less than 8 electrons. They want electron density. And so anything that will stabilize a carbocation also works for a radical. Hyperconjugation through more substitution, right? Secondary is more stable than primary. Tertiary is more stable than secondary. But the biggest thing that really, the thing you want to look for when you're looking for radical stabilization is resonance, right? And you can, so this is the big thing to look for. Resonance stabilizes radicals in a major way. All right, here's how. If you form a radical next to a double bond, we can draw a resonance structure here where we take this one electron, represented by the fishhook arrow, and one electron from that double bond to draw the following resonance structure. All right, and this radical is delocalized. It spends some of its time on this carbon, some of its time on this carbon, and we say that it is delocalized. So when you're asked, to find the major product, we want to find the most stable radical. And when you look at this molecule, there is one spot that is a clear winner. All right. As we know, having a radical next to a benzene ring would be more stabilizing than a alkene, because the benzene ring has 3 alkenes, right? Well, what about forming a radical next to 3 benzene rings? You can see that this radical, if it forms here, would be stabilized by 3 aromatic rings, making it crazy stable. Far and away more stable than any other site on this compound where you could do a hydrogen abstraction. So the answer to this question, when you're asked to predict the product and then rationalize the regiochemistry, is as follows. So, whoa. Sorry, that was an ugly, ugly, ugly benzene ring coming into the world. There we go. So starting from this substrate, exposing it to these radical bromination conditions, we are going to brominate at the position that can form the most stable radical, which is here. So this will be our major product. And when we're asked to rationalize it, we can say that bromination at this site proceeds through a tertiary radical intermediate that is stabilized through resonance by 3 phenyl rings. Phenyl is the substituent name for benzene, if you're unaware. That is the explanation. Cool. So, so Fuzel, that is the answer to number 6. Hopefully that that was helpful. Okay, let's see. Why does that's weird, Raj? For me, it says Chem for 20 office hours. It might say Chem for 100 office hours. I'll fix it once the stream is concluded. But at least on my end, it's looking okay. Excuse me. Totally. It was my pleasure to answer. That was actually a really fun problem to look at. What is a benzene ring? That is a great question. Oh, dude, no worries. So, benzene is the following molecule. It is a 6-carbon ring with alternating single and double bonds with the chemical formula C6H6. And so whenever you, so this is the molecule benzene. But whenever you see that structure as part of a molecule, you can say like, oh, there's a benzene ring in that molecule. They just mean that, or I just mean, anyone just means that there is a piece like that is part of another molecule. And this thing has a substituent name of phenyl. So, for example, this compound would be named 1-phenyl. Benzene. Because one of these rings is the benzene parent, and the other ring is a phenyl substituent. So you don't say benzyl, you say phenyl is the substituent name. Yes, one line is a single bond between carbons. Totally. And then 2 lines would be a double bond. Only on a side chain. So, carbon needs 4 bonds. Totally. So, for example, if you look at a molecule of benzene, and let's say we're looking at this carbon, we have 1, 2, 3 bonds, but we know carbon always has 4. So that means there's one CH bond that's there that we didn't explicitly draw. And that's actually the case for every carbon on this molecule. So that is that. This is called skeletal structures, or sometimes they're called line structures, stick structures, sticks and bones, may break my bone structures. That's that good business. Alrighty. So I can see that we have, let's see. Well, I know Raj and Fuzail are here. But that means there's still 2 lurkers in the dark. I was saying earlier, if you're new to the stream, that the way YouTube does live streaming is I see my total concurrent viewers, but it does not tell me who those viewers are. So I know that Raj and Fuzail are here. But I don't know who the other 2 of you are. So it's like they're sitting here in this room, and then in the shadows there's 2 more humans, and I know they're there, but they're kind of veiled, and they're I can't see their faces. They're all in shadow. So feel free to come out and ask a question. I won't bite. I promise. I don't even write the exam, so there's no way for me to bite, right? Let's see. And I'm totally down to take any more questions. We have exhausted everything from email and Canvas at the moment. So are there any fresh questions out there? The stream's been going strong, almost an hour. Oh, let's see. And the longer strands are parent strands. Yes, totally. Yeah. Oops. Hang on, cancel. Totally. The longest consecutive sequence of carbons is called the parent chain, and every branch coming off that main chain is called a substituent or a side chain. Totally. I am down to hang as long as questions are flowing in. Oh, dude, totally, totally no worries. Totally no worries. It's good to see you. I feel like we're all kind of trapped down in our caves, and we can like come up for air, and it's nice to see your digital face. I really miss teaching lab. You guys are really, really cool to hang out with. I actually bumped into Catherine the other day. I was writing with my kids and my nephew on. I was riding on my one wheel; they were on some bikes, and we were going down a road, and I bumped into her. She was taking a walk on the same kind of walking paths through Folsom, and we, maintained social distancing and everything like that. But it was like, dang, of all the semesters to get cut short, you guys were a super cool lab, and I miss seeing everybody. Digital hanging out is cool too, I guess. But yeah. Let's see. So substituents. Okay, sweet. Substituents always have alkyl substituents do. And alkyl equals from Mallory's brother, what is my take on general relativity? Well, that is some hardcore physics right there. I'd say in general, it seems to be a little relative. Relativity is totally a thing, and part of the way we know it is as it turns out, our GPS wouldn't work without it. The fact that the satellites used for GPS are up in the atmosphere at a different point in the gravitational field than we are down here. They have to correct for relativity when it comes to like broadcasting our position accurately. So it's totally real. We base technology off of it. Google Maps or Apple Maps or Crapple Maps wouldn't work without it. So yeah, that's kind of my hot take, my 2-second take. Am I qualified to like debate the nitty gritty of it? Totally not, because I'm an organic chemist, which I heard once. Organic chemistry described as being chemistry for the right-brained. So it's kind of like the art scene of the STEM world, where you tend to be very visually driven and less mathematically driven. So as a general rule. But that's my hot take on general relativity. I don't know if it's what your brother was looking for or not, but that's my 2 cents. Looks like we've... Oh, wait. Here we go. Yeah, man. Anytime. Whoa. Now I'm going to use my favorite emoji. You can only use this emoji on the YouTube Messenger, so I try to work it in at least once a stream. I wasn't able to... earlier when I did my Gen Chem lecture, there were no drop the mic moments, but there I feel like yes, Raj, that is your dab. You showed me the emoji dab, and I'm an addict now. So it feels like we're hitting a little bit of a dead spot in the stream. I'm totally obviously down to keep going. If you got more questions, totally hit me. But as we're kind of in a lull, here's a little thing for all of you. Our song of the day, which is already linked in the description, is Megalodon by a mastodon. I have to say up front that I'm disappointed. I have to say up front that I am by no means a metalhead. I've always gravitated to punk more than metal. But that being said, I do have a soft spot in my heart for stoner metal, and you can't do much better in that scene than Mastodon. This is off of their second album, which is loosely based off of Moby Dick. It's not a strict interpretation. It's loose. It's thematically based off of Moby Dick, called Leviathan, and you should check it out. It's a little intense. Not if you're already a metalhead, though. Oh, is there anything higher than octane? Yeah, man. Carbon chain. Yeah, dude, Raj, you can get so much higher than octane. For example, nonane has 9, or decane has 10, or undecane has 11, or dodecane has 12. And it keeps going up from there. There's no limit, really, to how long you can make carbon chains. As far as naming goes, I only know through 12. So I don't imagine you need much higher than dodecane. But there's huge carbon chains, like in our bodies, proteins, enzymes, amino acids, all that stuff. It gets really big really fast. Any other questions out there? Let's see. How are formaldehyde, acetaldehyde, and propionaldehyde different? Well, the answer is has to do with the carbon chain. I think this one's actually easier to answer in the comments. Formaldehyde has 1 carbon in its carbon chain. Acetaldehyde has 2 carbons. Propionaldehyde, it's a mouthful even for me, has 3 carbons in its carbon chain. So the difference is just the length of chain. And acetaldehyde and propionaldehyde, and formaldehyde for that matter, they're common names that are accepted by IUPAC. De nada. Nope, let's see. Might have a new email. Oh, nope. No new email. Let's check it again just for fun. Yep, nope, nothing new. Actually, they So, question: are sugars aldoses or ketoses? They can be. Aldoses and ketoses are different types of sugars. Of carbohydrates. The difference really between a aldose and a ketose is an aldose has, so they all carbohydrates have a a carbon oxygen double bond, but the ketose has the double bond on the internal kind of backbone of the carbohydrate, so it's a ketone, whereas the aldose has a carbon oxygen double bond on the terminus, which makes it an aldehyde. So that is the difference between an aldose and a ketose. It totally does. Totally. Sugar chemistry is like the beginning of biochem. Totally. Are there any more cues? Oh yeah, of course. Of course, thanks for stopping by. Totally. It seems like things are starting to slow down in the absence of any new questions. I'll be logging off soon. Totally up to you. I'm like I said, I'm down to stay till 9:30 every night. If you guys have questions, we're discussing things, we're talking through things, I'm 100% down. In the absence of discussion or questions and stuff, then I'll call the stream early, but I'll give it maybe a few minutes or so. I am at the moment currently. So I finished up our first, not our first, our second 100% digital lab report. And I'm typing up an announcement to post that. So that is about to drop. right. So again, take a look at it. The so let me open up a slide here. So we have a new online lab drop-in. It's due a week from today. On 4/20/20. So I'm getting ready to write the post. It's posting to Canvas tonight. All right, posting to Canvas tonight. Yeah. It's about radical chlorinations and GCs and product distribution. It's pretty cool. I got to write this one, which was fun. And I hope you all enjoyed. I'm totally down to answer some questions if they arise. So take a look at it tonight. See what looks doable, what looks challenging, because we have office hours again on Wednesday, so you'll have an opportunity to get some help on it before it comes due. Alrighty. But I'm sorry, I'm writing out this Canvas post as I speak. Let's see. Last call for questions. If not, I'm going to conclude our live stream. Alrighty, well, I think I'm going to call this a night. Thank you, everyone, for joining in. It was fun to see everyone, including Mallory and Mallory's brother, Raj and Fuzel. Always a pleasure. Hopefully you found tonight's office hours helpful. Again, remember, you can, if you can't tune in live, you can always email me your questions. Put Chem 420 office hours as the subject line, include a picture of the problem that you're struggling with, and even if you can't attend live, your question will get answered, and I will, in the description, do a time signature outline for the video so you can skip right to the part where I answer your question. So you don't have to watch the entire stream to find that one thing you needed an answer for. Anyways, it was good to see everyone. I hope everyone had a wonderful spring break, and I will be back here next Wednesday. I look forward to talking some more chemistry. Have a good night, guys.